AIFI information session. Um, my name is Jeff Brown. You've probably had one or two emails from me, one or two phone calls from me in the last few days. And I'm basically, I've spent the last, over 2 decades responsible for a variety of educational programs, primarily in the financial services sector. And of all the programs that I've helped with, including the FRM, the CFA, the CQF, and various others, the AIFI is, I'm sure you'll find out during the course of this information session, is in a league of its own. It's incredible. And one of the main instigators for that is Miguel Alonso, who founded the AIFI, the Artificial Intelligence Finance Institute. Miguel spent over 2 decades, well over 2 decades, in the financial services sector in a number of different positions, senior positions. He's also taught and teaching at NYU, at Columbia. He's an advisory board member of the CFA Society of New York as part of the quantitative investing group. He's been there, he's done it, and basically over the years he's made a lot of friends, a lot of contacts in the industry, particularly in relation to AI. And he's come up with this extraordinary program, which is delivered by some of the world's leading quants, genuinely leading quants. Some of them are quants of the year. They're authors, academics, practitioners, and they've designed an incredibly applied program. So I really hope that you find this enjoyable and useful. And Miguel, I will pass over to you.
Okay, Jeff, thank you very much. Again, it's for us a tremendous honor, so to speak, to be presenting, to be talking about the 12th cohort of the AIFI Bootcamp, which is an N certificate. So I'll be talking about the bootcamp and the certification that you can get. Thanks, Jeff, for this nice introduction. It's indeed true that we started, so to speak, early in the game, in the sense that back in 2018, so almost 6 years ago, Michael Weinberg and I, Michael Weinberg, who's now at Columbia Business School, had the idea of listen, we have some sort of new generation of tools, right? Like machine learning, reinforcement learning, NLP, that weren't obviously as popular as they are today in 2018, and we had this idea, and we implemented the idea of founding an institute that some sort of gathers top academics and practitioners in the world of AI in finance, artificial intelligence in finance, and we some sort of produce, I think, an excellent program in which we combine, the most rigorous maths, but also, lots of code, PyTorch, scikit-learn, TensorFlow, and so on, right? And in addition to, obviously, the elephant in the room, which is the large language models, which we obviously have incorporated in our curriculum, in our lectures. And again, we had and we have our purpose, our main goal is to spread and train and do research on AI in finance. So this is the 13th cohort, right? So 12th cohort. So we have an online program running from the 14th to the 25th, streaming every day around 5 hours, right? Starting at 9 a.m. EST, and everything is going to be recorded, right? So um, there's no problem if you can attend, so to speak, the program in the live sessions, right? But obviously, again, the recordings will give you the flexibility as well as all the materials in the program, right? So we will be sharing around 100 notebooks, which cover pretty much all topics that we will see in a platform that we have, and the course is aimed for quantitative analysts, computer scientists. So it's somehow, that AI, some sort of is kind of, computer science is kind of taking over finance also, in the sense that algorithms are doing things, non-parametric algorithms are doing things that were done before parametrically or by humans, and again, now we have the large language models that it's one step more in the automation, in the full automation in finance, with chatbots, with financial agents, with reinforcement learning. So let's say a whole new finance world that it's ahead of us. So again, this program is unique in the sense that we provide, coding training, we provide math training, and so on. So other some sort of shorter courses are more focused on some sort of the hype and so on. But you'll see when I present the contents of the course that we have a really deep some sort of coverage of all important topics. So Geoff produced some sort of a very nice introduction about my profile, but yes, I just thought that again, in addition to a very, I think, relevant experience as a practitioner, I am professor at NYU, Courant, Tandon, right? I've been also professor at Stern at NYU, previously at Columbia University, New York. I've also taught in Imperial College, London Business School, so pretty much all top, I would say, universities in New York, right? And I'm if you're happen to be in New York next week, I'm giving a talk at Cornell on Monday, right, to talk about again the impact of AI technologies in finance, specifically talking about LMMs, large language models. So we also please visit our website. We also offering a large language model course, which is a shorter one than this one, and obviously this is some sort of more focused on the LMMs, large language models implementation in finance. As Jeff mentioned, so we had at the beginning, and we obviously still have the idea of trying to bring the best professors in the world to be teaching, cutting edge implementations, right? So we have pretty much all recent quants of the year, like Peter Colm, who's professor at NYU, previously the head of one of the best programs in New York, the Mathematics in Finance Master, and he's been previously at Quantitative Strategies at Goldman Sachs Asset Management, and he's the author of numerous academic articles and 4 books. So he's working with us since the beginning, right? Also, I want to mention the fact that Peter Carr, right, who died, 2.5 years ago, also had a tremendous contribution to our institute. Unfortunately, he's not with us anymore, but certainly we have enormous gratitude about what Peter Carr who was professor at NYU and author of jam diffusion models and other, some sort of brilliant stuff. So thank you very much. We also have Matthew Dixon, who's, I would say, one of the best authors and researchers in regards to DL in finance, deep learning in finance, and reinforcement learning in finance. Matthew Dixon is not anymore at Illinois Institute, so he resigned and now he's doing other stuff. But we have the enormous privilege that he wants to teach for us, obviously this fall semester, right? This fall bootcamp. So we're very, and also, and I have an enormous gratitude to Matthew. And needless to say, he's, as I said before, one of the most important researchers on this area in the world. Two other giants that are also involved is Gordon Reeder, who's I've have a special admiration for people like Gordon Reeder, who's PhD in mathematical physics at Harvard University in 2007, so a while ago. And Gordon is a little bit like myself, right? He has been teaching and he's been teaching on the three nations leading MFE programs, Master in Financial Engineering programs, Baruch College, NYU, Courant, and Chicago, right? And Gordon has an incredible sort of track record of academic research and again teaching at the highest level, right? There's an anecdote with Gordon Reeder that I always like to share, is that Gordon taught a few years ago, right, a course at Harvard about Riemann surfaces, and his teaching assistant when he was teaching that was Maria Mersandani, who was the first woman who won the silver medal, right, in mathematics, and unfortunately she left us a few years ago, right? But also collaborating with the Institute, Marcos Lopez de Prado, who needs no introduction, I guess, for the audience, but Marcos has been one of the most accomplished practitioners and also, let's say, researchers in this area, right? I still remember vividly when he was at Tudor that I once visited him at when he was at Tudor, right, and in Connecticut, right. I remember discussing with him back in 2007 some super vector machines for finance. Like, okay, so back then was kind of a very, very innovative, right, to be using super vector machines in 2007. But I remember vividly, right, that we were discussing some of these again, right, very, very cutting edge algorithms back then. Okay. Stefan, okay. Another interesting thing is that you'll see that we have in our certificate, in our program, some sort of literally all the authors of the best books in the area, right? Because Matthew is the author of machine learning environments for theory to practice, along with Paul Villacon and Igor Halperin. Obviously Marcos, who's the author of several, right, very, very successful books, very interesting books about financial machine learning. Marcos is now at Cornell, but is now working at Abu Dhabi Investment Authority, right? Okay, so Stefan Johnson is the author of Machine Learning in Trading, and he's going to give us some of the most interesting sessions about deep learning in finance and unsupervised learning, right? So we'll see that. And also Stefan has been with us for already around 5 years. A very, very important contributor for everything we do is Nicole Konigsteen. So Nicole Konigsteen is a distinguished data scientist, quantitative researcher. She was working at Impact Buys, right? And now is some sort of changing a bit the company. And Nicole, she's the coding instructor, so to speak, and she's also the author of two very interesting books. One is Math for Machine Learning, and the second is one that is about to be published. It's I think almost finished, and it's about transformers, right? So I guess that you know, almost everybody in the audience know what transformers are. You know, the most, let's say, the most successful deep learning architecture, who's at the heart of you know, the most successful uh, AI, some sort of machines, who are the transformers. The first transformers were somehow were invented by Bajbani and collaborators back in 2018, and again, you know, so she's wrote a book about transformers, right? So we'll have you know, quite a lot of um, again coding time during the course. We've learned over the years that delegates have told us, you know, it's obviously very important to the maths, and we'll spend time about the maths and time about and time about implementation, and time about you know, having some sort of an understanding what the algorithm does, but also the fact that once we finish the bootcamp, delegates should be able to implement, right, interesting, you know, AI models, like, for example, reinforcement learning or NLP, natural language processing, LMMs, and so on. So the course is intended to be pretty practical, and as I said before, we're going to be giving up, you know, lots of notebooks that will help you navigating. So if you've never coded, so to speak, right? So I'm not saying that you can learn to code in 15 days, right? So you should start but right now if you want to take the bootcamp. But certainly coding today with the help of all the notebooks that we'll give and the help of the large language models, Claude 3.5 Sonnet or GPT-4o or Gemini Advanced, so you can some sort of, right, go very far, right, and let's say speed up the learning process when it comes to Python, PyTorch, TensorFlow, scikit-learn. So we've been publishing, especially for the last 2 years, some sort of lots of papers, right? So the best way to see them is, you know, you go to SSRN, to my page, right? And we have, you know, we have already 36 papers, right? And we're working in many more, right? So interestingly, also our professors and many of our students, right, have been working in very, very interesting applications. So if you are interested into into researching or writing papers with us, right? So send us an email or reach out to me on LinkedIn. So one of the most famous papers are by equity machine factor models with Vincent Zunekind. With Vincent, we have a very strong collaboration, and we will be publishing soon a very interesting one. I can't say more. Then we have, we're proud to say that we were some of the first to start saying that LSTMs, long short-term memory networks, could be useful for Financial Times series. So we started saying that in 2018, we rewrote in 2020, and I would say now people is less afraid, so to speak, or people thinks that LSTM should be in the toolbox. Also, we've been writing also about deep reinforcement learning, several papers, a generative time series using variational autoencoders, and so on and so forth. Also, just one paper which I'm very proud of is this physics-informed neural networks in finance, along with Julian Antolin, right? But go to our SSRN, and again, obviously, all the other, right? All papers that Matthew and Marcos and everybody has been. Okay. Now, one of the reasons that this year we're not offering the bootcamp in summertime was the fact that we have actually 3 books coming out. So we have one giant book called Artificial Intelligence in Finance that you should see in your screen that we will be publishing in October, end of October 2024. So we wrote the book with Daniel Bloch, who's a PhD Oxford mathematician, a veteran on quantitative finance, with an incredible some sort of understanding and some sort of the mathematical finance, and also with David Pacheco Aznar, who's been writing with me, a young and super talented computer scientist who's been writing the book with me. So the book is 2 volumes actually. One that is supervised and supervised, the intro, NLP, and reinforcement and supervised learning. The second volume, who's going to be probably out in December, is going to be basically 2 things. One is going to be a revision, an extension of the current approaches of reinforcement learning in finance. So we have a tremendous hope that after LMMs, right, which obviously have and are impacting finance as we speak, then we'll have lots of reinforcement learning applications. So you'll have I think a very nice reference in the year end. So that's one of the reasons that we wanted to have the books out, and then and at the same time some sort of doing the bootcamp. So you'll be the first ones to some sort of see all the new materials we've been working on, right? There's a third book. A third book is also about to be published by this one. These 2 are risk books, right? As a publisher, and the third one is with Willy Finance, right? So with Willy Finance, we have written with Julián Camarena and Alberto Guerrero. I think a long due revision of quantitative portfolio optimization. So they're very good books, obviously, on quantitative portfolio optimization, starting with Markowitz, 1952, and so on and so forth. But since 2010, right, there's been just not a lot of literature that updates what are the current approaches on quantitative portfolio optimization. So I think this is going to be a nice reference, and the book will be also out right? And in addition to that, we're working on another book on LMMs, large language models. But okay, so let's move on. These are the so to speak all references, but they are still very good. So the one big data and with machine learning quantitative investment with Tony Guida, who's also on our faculty. Machine Learning in Finance, who's still a fantastic book with Matthew, Igor, and Paul, and all the Marcos and so on. So let me move on. Okay, let's focus now. I'll spend around 15 minutes talking about the contents of the course. So we'll start in the 14th October, 9 a.m. EST, or we'll start streaming, right? Again, we'll record everything, and then you'll have some sort of obviously around 6 months of access to our platform, but you can download also the sessions. Okay, in the first we will discuss pretty much all the, I wouldn't say introductory, but all the, let's say, all the materials about the framework, right? So how we can build a robust framework when it comes to using or starting to use artificial intelligence in finance, like the modeling framework. How does this fits with quantitative finance? And then we'll start with supervised learning algorithms. This is an AI course, but we still think that there's value in seeing what algorithms somehow people think are a bit old, right? But obviously we'll spend a bit of time with obviously trees, ADA boost, XGBoost, cat boost, and all that kind of stuff. And we will have every day is going to be around 3 hours lecture and 1 hour keynote. And the first keynote is going to be delivered by Better Call. The second day we will finish these some sort of what we call now machine learning algorithms, like super vector machines, classification and regression trees, XGBoost, CatBoost, and so on and so forth. And we'll start the first coding session with Nicole. Okay, so Nicole offers again fantastic coding sessions, and we'll start the first day by the basics, right? So let's say we really recommend everybody takes them, right? And if you enroll in the course and you've never coded, we will offer some primers, right? We're just working on them. The third day it's going to be what I typically call the retreat day, right? It's not the tree day, but obviously 2 hours of ensemble models, random forest ADA boost, XGBoost by Yasheng Zheng, who's a young Chinese American researcher based also in New York. Alejandro Dominguez is going to be sharing some recent advances on portfolio management causality. Papers are not called that way. You can find Alejandro's papers out there. He's also be writing a chapter of our KPO book, Quantitative Portfolio Optimization. And Alejandro Dominguez is doing a tremendous contribution of this important idea of introducing causality into portfolio management. We'll continue with William Kelly, who's the CEO. Well, who's recently he's been the CEO of Kaya, of the Kaya Institute. I'm sure many people in the audience know that there's several certificates offered by Kaya, right? These alternative investments. And William Kelly is a veteran of the asset management industry. And we will finish the day with Daniel Block, again, a PhD from Oxford, a very accomplished quant finance expert talking about neural networks and jump models. On the day 4, we will start with some sort of unsupervised learning. Well, it's 2 hours, so Stefan is going to go through, some matrix factorization, like PCA, SBD, singular value decomposition, also, k-means. And then we'll start looking at deep neural networks used for unsupervised learning, like autoencoders, variation autoencoders, and so on. On day 4, we'll have the second coding session, right, which is now 2 hours, and here we'll basically see a lot of scikit-learn. With Nicole, we have a GitHub that is private. You'll have access to it, again, with a bunch of very interesting notebooks that our delegates also have found very interesting. We'll have a speaker, Anil Sood from Ernst & Young, talking about some of the important aspects of governance and safety and so on about large language models, right? On Friday, 18th of October, day 5, we'll have very interesting session, right? It's one of my favorites, right? We kind of, invited Francois Charton is a meta researcher, previously Facebook, and Francois was one of the pioneers of something really interesting, which is the use of transformers, right, to do mathematics. Okay, and he's delivering some sort of a really beautiful session talking about how transformers be used. Also, again, transformers are at the heart of LMMs, and Francois and his team, let's say, they started doing way before, right? Not way, but let's say 2019, 2020, they started writing papers pre-LMMs, okay? But transformers were already popular, right? Because of BERT and some others of the, let's say, first deep learning models in NLP, in natural language processing, that were already using transformers and not LSTMs or recurrent neural networks, which was the technology used, pre-transformers. Dani Cajas is going to be talking us about graph portfolio theory. So one of the approaches that can be used also to deal with portfolio allocation problems, it's graph portfolio theory, right? And Dani Cajas is I would say one of the leaders on one of the most interesting researchers in this area, right? And he also has a wonderful GitHub that I highly recommend, and so on. We also cover in our quantitative portfolio optimization book some of his interesting models. Stefan Jansen is going to be, doing a very interesting session in which first we some sort of take a deep look at deep learning, right? Which obviously we are trying to what we are doing in let's say in the last 2 years, we are reducing and adapting some sort of the contents of the certificate of the course to let's say an increasing level of knowledge on our delegates. So we are introducing new stuff and cutting on the introductory stuff, which our delegates say that they kind of already know. But Stefan Jansen is going to be talking about what I like about this session is about these implementations that he shows, right? When it comes to factor models, right? So factor models will also be an important part of obviously. I'm gonna be talking about the three areas of quantitative finance and how they're covered here, right? But certainly, factor models, it's one important area. On Monday, right? On Monday, 21st October 2024. So we will start with Daniel Bloch, who's going to continue with this jump model neural networks, new research. David Pacheco Aznar is going to be talking us about, UMAP, and BAEs. We're also working in new research in copula, using copulas, BAEs, variational autoencoders, invented in 2014 by Kingma and Wellick. And we find BAEs like a very interesting tool for finance. So we'll see quite a bit of BAEs during the course. Then, well, on Monday, we'll have the first session by Matthew Dixon. So Professor Dixon, is going to be talking us about, advanced, so to speak, what was advanced, right? Recurrent neural networks, LSTMs, COPNETs, convolutional neural networks, generative adversarial networks in two contexts, basically. In the context of time series, which is also something that many delegates find really interesting, right? Because they don't see that anywhere else, right? Also time series, we will be introducing something we're working is exactly this week, which is time elements. Okay, so large language models that some sort of are, so to speak, specialized in time series. So GANs and BAEs will also be there. So this is the second deep learning session. So deep learning obviously is going to be used everywhere, but we think that let's say two sessions, some sort of instructed by Stefan Jansen and Matthew Dixon, or I would say state of the art in the matter. On the 22nd, we'll have deep learning coding with Nicole, and another very interesting session, which is reinforcement learning. So we'll start talking about reinforcement learning. So, there's three, let's say, machine learning, the way we were teaching, right? And we are teaching a little bit before LMMs was supervised learning and supervised and reinforcement. Reinforcement learning is the idea to be prescriptive, so to speak. They use POMDPs, partially observable Markov decision processes, to some sort of model sequential, let's say, decision-making problems. So that's why we say prescriptive, because you actually want to use a model which is looking at the states of the world, and it tries to find the optimal policy. The policy is a sequence of actions that maximizes the reward function, so to speak. So we'll see all these issues, right, about Markov decision processes, taxonomy of RLs and Bellman equations, and all that kind of stuff, right? Again, our book is going to be out, probably a little bit later on. So we'll start seeing some of the new developments that we've worked with Danny Bloch on this area, right? And so one of the co-authors of this reinforcement learning second volume of our, opus AI in Finance is David Pacheco, who wrote some sort of a wonderful some sort of master thesis about reinforcement learning. So I think that we have literally everybody, right? Not everybody, but let's say pretty much all the most important researchers in the area of RL in finance are going to be talking and teaching in the bootcamp. Gordon Reader, David Pacheco, Danny Bloch, Matthew Dixon, and Igor, who's going to give a final keynote talking about some of the interesting applications. Okay, and then the last 2 days, the 9th and the 10th, is going to be, the NLP slash LMM, right? Large language models. Why we, let's say, let me go back a bit, right? So also already in 2018, ourselves, we started doing a lot of NLP, natural language processing. Back in 2018, we were everybody working on NLP was doing sentiment analysis or derivatives of that, and we were using some sort of what it seems now, let's say the dark age, not the dark ages, but obviously the beginning of useful NLP. We still think it makes a lot of sense to see a bit of to do a bit of NLP, right? Of the old NLP frequencies, right? And LSTMs, bilinear, bidirectional LSTMs, and all that kind of stuff, right? Because some of the problems are common even when we do LMMs. Asier Gutierrez, who's now at Walmart, right, doing NLP for Walmart, the U.S. retail giant, right, was one of the pioneers of using BERT at the beginnings of BERT, like in 2019 and something like that. We started and 20 we published a paper called Phineas using to some sort of to do financial sentiment using SentenceBERT, who's a model that let's say instead of finding a better representation of the tokens is working in sentences, and we found that that was a useful model, right? And that is a useful model. And then we start with Bashkarit, who's at BlackRock. Also, BlackRock is doing lots of things using LMMs. We're doing lots of things with them. We're doing large language models in investment management. And Arpit Narain, who's going to be talking more about LMMs in finance. Then the day 10 will have 3 hours of LMMs, right, with myself and Richard Rothenberg. So in this our coverage of LMMs is about, LMMs are like GPT-040, like Sonnet, Claude Sonnet 3.5, and so on. Are out of the box already pretty useful in finance, right? You'll see some of, I wrote 2 papers recently with Anane Dupuy, who's helping us on the LMM certificate side. She's an algorithmic trader in Paris working for a French bank. And, out of the box, LMMs are very useful in finance, right? But obviously, fine-tuning, retrieval augmented generation, even the use of reinforcement learning for human feedback, DPO, and so on and so forth, might help and help, some sort of build more robust models when it comes to these LMMs that can be used in finance. Why is that? Because, LMMs haven't been exposed to all, let's say, knowledge that it's needed to do finance well. For example, papers, for example, books, for example, equations, and so on and so forth. Our job is obviously to feed that into an LMM if we want to work in a specific area. The other obvious thing is the idea of reduce hallucinations, right? Okay, LMMs are producing hallucinations, right? Hallucinations are mistakes. We prompt something, we ask about, I don't know, we might be asking about what are the revenues of Apple in the third quarter 2024, and maybe, the machine, so to speak, hallucinates and gives us the second quarter, right? Or maybe, it mistakes, this doesn't happen, but it's just an example, mistakes Apple for another company or for another concept, and so on and so forth. So hallucinations are, are obviously, everybody that's working hard in elements will tell you hallucinations are inevitable, right? Um, um, and some others will say, okay, no, RAG solves everything. We kind of have a middle ground, some sort of opinion on that. And LMMs in finance can be very useful. You can reduce hallucinations to a very, very reasonable level, and so on. User cases are, almost, everybody, everywhere that you have text, you can be using elements to produce new text, to summarize, to review, and so on. Everywhere where there's code, you can also use elements to produce code, to check code, to review code, to document code, and so on. It's not perfect, but it's helpful. It's pretty helpful, right? And also, we have found that, and we're also, writing papers on this, that some LMMs are especially good at dealing with maths, with mathematics. Okay, so that is not common knowledge. People tend to think that because an LMM is some sort of, sometimes it makes silly deductive or silly logic, kind of statements, it means that it's a stupid thing I cannot use for sophisticated things. It turns out that LMMs sometimes do very well, very sophisticated stuff, and deal less well with dumb stuff, or stuff that for a human seems kind of dumber, and it seems kind of an evident thing to do. Okay, so again, a lot of energies and a lot of materials you'll have access to, where in addition to materials that are not even in the street, so to speak, like uh, these time elements. We'll continue with Richard Rothenberg, who's gonna talk about NLP finance. Richard Rothenberg from Global AI is one of the pioneers of the use on NLP. He started doing NLP back in 2018-17, when literally the first applications of sentiment in finance were born, right? Okay, using frequency basically, right? Using TF-IDF and all that kind of stuff. If we'll finish with Igor Halperin, who I guess needs no introduction, but is also one of the quants of the year, right? You can count this kind of 5-6 quants of the year, right? In the faculty, and he's gonna talk about reinforcement learning. Okay, let me talk about evaluation. Okay, I think one of the most interesting, right, sort of value added of our bootcamp is the obviously the idea of passing the exam and delivering on the AI finance project, and then you'll get a certificate that's starting to be recognized, right? again, the difference between our offering and others, right? First is that this is really AI and ML since the beginning, right? So we have a long experience teaching LSTMs, transformers, SBMs, NLP, reinforcement learning, and so on. When literally nobody was almost, when only a few. There were a few courses in the United States, I think, when we started ourselves talking about RL in finance. I think there was only one course in Stanford, right, back then, right, and there was literally no NLP in finance and so on. Okay, and compared to other things like founders and some others, here is not about knowing about user cases and the hype and the so on, but it's about implementations. It's about the code. You'll be able to write useful code. So the theory exam for the cohort of the fall semester is going to be the 11th of February 2025, so 3 months after, right? One might, once you take the bootcamp, you'll see that people get scared and says, oh, there's a lot of materials. I will not be able to absorb that and take the exam, right? But the reality is that a fair amount of people finds useful that taking the exam 3 months after. So in 3 months, they have time to go through the slides, obviously the recordings, the code, and so on. The exam is open books. So it's not a memoristic, or it's not a mathematical to the force and so on. I would say that some sort of a reasonably accomplished financial engineer who has been paying attention to the algorithms and the frameworks and so on should be able to pass it, well, as the historical shows. And then, in the 13th of May, is 2025 is the AI in Finance project, okay, which is an implementation of AI in Finance. Okay, just quickly, well, I have a few slides that we typically, is like, supervised learning and supervised enforcement, right? And here I have a couple of slides that are pre-LMMs, so to speak, because and in which we see that pretty much, all algorithms, right, or pretty much AI can be used everywhere, right? That you need portfolio allocation, because instead of doing a quadratic programming, MPT, sorry, modern portfolio theory kind of optimization, you can do reinforcement learning to do portfolio allocation. Obviously, all the supervised learning models can be used to do alpha generation, so the prediction of expected returns, option pricing, right? You can do reinforcement learning. We can do supervised learning. Why reinforcement learning? Because you can some sort of tell the algorithms, can you learn, for example, to do delta hedging and all that kind of stuff, right? Also, the reconstruction of volatility surfaces. So there are lots of different problems. In risk management, I think we're going to build a new generation of tools, because generative models, which are basically generative models, can also be seen as a joint probability distribution of the axis, right? So supervised learning is the joint probability distribution of the y's and the x's, right? Okay, and unsupervised is P of X, right? X being this giant matrix of data, so to speak, right? So the fact that the models have shown that they can operate well in high dimensions, right? Maybe better than parametric models, right? Okay, so I have a little bit of a, no, I wouldn't say a controversy, but with my current colleagues, at NYU is the idea of you look at parametric probability distributions and you're very surprised that we basically have 5 or 6, right? Or 7, right? No, you don't have a lot of them, right? And actually working well with them, it's the Gaussian and the studenty almost. I'm not saying that so so when and that's one very good explanation of why we need AI, right? Pretty much in all environments in which we have a high number of dimensions, right? We are almost surely going to need or want to use right AI algorithms or machine learning algorithms that have shown to operate well in this high dimensional, relatively low data kind of regimes, right? So for risk management, I think it's also somehow a new era in which once we get more comfortable using BAEs everywhere or copula VAEs, variational encoders, right? People will start, why I'm making so much emphasis also on generative models is also because you're going to be able to generate scenarios, right? With generative model you've learned and so on. In addition to scenarios that can be some sort of explored using LMMs. So here we can say LMMs, large language models, will be an essential tool for risk management, right? And now people is surprised and saying, "Oh my God, right? This is kind of this." CS people never told us, right, that LMMs were also for generating scenarios and so on. Some of the most important, user cases that we are observing in the market by quants are actually scenario generation by LMMs. Let me give you an example, right? So Deutsche Bank, right, for example, was saying, okay, I'm gonna launch a quant product that is based on inflation. Okay. So stocks that kind of react well to high inflation, react well to very low inflation, or stocks that react well or bad to actually deflationary environments. We have actually never witnessed in listed, let's say, in listed developed markets, deflationary environments, right? So Deutsche Bank then said, okay, who can help me? Obviously, my economists, right? My portfolio managers can some sort of make the case of what's going to happen if there's deflation with oil stocks, right? And so on. But I can also talk to the LMM, to the large language model, right? Okay, so NLP task and NLP, it was kind of here the last, so to speak, the last 2 days, and now again is kind of, taking over, right, with LMMs that are so easy to use and they're so amazing for banking, actually, right? So there's a yeah. Yeah, let me answer that's a very good question, right? So let me, okay. And banking. So banking was kind of obviously, banks were not the place for the quants, but I would say since 2020, even 19 was, the emergence of big data. Banks started to some sort of to build armies of data of data analysts, so to speak, right? Um, Data science persons or data scientists. Okay. There's a lot, pretty much, you see here pretty much all core functions in a bank are kind of a sort of a supervised learning problem, an unsupervised or a reinforcement learning problem, even pre-LMMs, right? The impact of data science in banks has started to be huge, right? Obviously, the use of less people everywhere makes that, okay, you should characterize, for example, your clients, right? So you should be clustering, so to speak, financial DNA, personal DNA, and so on. You should also be, thinking about what to do next with a client. What's the framework that helps us to say what to do next with a client? Well, you can do reinforcement learning. I'm not saying it easy, right? I'm not saying is banks are gonna, but certainly, the scientific tools, so to speak, that you would need, that you need is reinforcement learning, probably coupled with a generative model, right, and so on. Then you have marketing, now LMMs also can help you, building campaigns, right? In the past, we're saying, okay, campaign is because, you have to choose the clients and so on. And then risk management. Okay. Now we have a question, a very good one, and it's how time series fit in all these, right? And time series and option pricing, because stochastic processes are sequences of random variables, right? And why do you need that? You need that in two areas, basically. In option pricing, because you need to price an option and you need to model the stochastic process and so on, right? And then we are pretty comfortable. Let's say the industry is pretty comfortable with parametric models, in the sense that Heston, Bates, are pretty decent models, right? That you probably don't, you're not going to change your pricer with a neural network pricer. If you have a 5-parameter Heston model that works well, you're going to go with that, so to speak, and so on. But you'll use neural networks for probably automatic differentiation, for delta, for the hatching, or reinforcement learning for the delta hatching, and so on. And then we use stochastic processes and ARMAs and ARIMAs and all that kind of stuff to do time series. And there, the question is, right, how can I produce some sort of expected return prediction of this time series, right? And the answer is, well, we'll see in the bootcamp. LSTMs can be useful. Transformers are probably less useful, because their transformers are probably more suited for, obviously very suited for words, maybe not suited for other sequences. And there's the overarching question of LMMs in financial time series. So we're finishing a paper in which we state that this is not an easy problem, right? Financial time series do have just very little structure, right? Language has a very strong structure, right? Okay. So that's what makes a 3-year-old being able to speak, or 2-year-old being able to speak and understand pretty much everything that is being taught, is being discussed at the dinner table, right? I'm not saying everything. You've just started, but let's say a 5-year-old is going to comprehend maybe 75%, right? Maybe a 90% if the discussions is about matters like the household, the school, and things like that. Well, anyway, my point is that language has a lot of structure, and certainly transformers have been able to learn the joint probability distribution of the next token pretty well, right? Also surprising us, because the fact that the transformers have learned that then helps the machine to produce almost perfect summaries of text, almost perfect. So we'll see that on the LMMs, but I'm less optimistic about LMMs with regards to time series. But LSTMs, obviously, XGBoost or trees, some sort of something that, right? and maybe other approaches, right? So we're working on some research that is not explicitly there's not explicitly AI, but it's the use of Boltzmann equations, right? So not everything has been invented already in regards to stochastic processes time series, right? Okay. And yeah, issues, right? So our time, when we do these models, is oftentimes, running algorithms 25% of our time, 75% dealing with interpretability, right? And dealing with, transparency of these models, dealing with fairness, and so on. In the United States, even if it's not an AI regulation, so all products it's required that are suitable, non-discriminatory, non-biased. They were already before any sort of AI involvement, right? Humans also had to produce products, so to speak, okay. So this is a tricky topic, right? A difficult one. I am actually more optimistic than others. And why is that? Why I'm not because I sell AI courses, right? But also because if you read my paper on AI, on LMMs as financial analyst, you ask GPT why likes Meta, and it's able to tell you in human terms that the mix of robustness of growth and revenues and product diversity and so on, you see. So that was kind of unexpected, right? But I think that LMMs will surprise us also in the sense that they can offer us explanations of why they say what they say, similar to a human, right? So why you say Mohamed Salah is the best right winger of the Premier League, right? So tell me why you say that compared to others, right? And you're expecting, the machine to tell you where it's because of GAs, right? Goals and assists, or it's because experience or impact in the games, and so on. So the same thing you expect for finance. So why you're not giving credit to that person? Obviously, you can build an XGBoost model and look at the tree and see we say no because you have a 5-year, I don't know, gap in your employment, and we don't understand that. So whatever, I'm inventing, right? But if you build a tree, you can kind of interpret, right, and so on. There also on this a lot of discussions, right? Because at some point we were all saying, oh, with Lime and Shapely, we're fine, right? And then we quickly discovered that Lime and Shapely are oftentimes not good, right? On local explanations, but global and so and all this kind of stuff, right? So interpretability, explainability is kind of I would say, and yeah. And my take here is that trees always emerge somewhere in helping you to provide interpretability. Then one other thing that I'm giving Q&A is this idea of data sparsity, data privacy. Okay, so differential privacy is a must these days, right? So you want to some sort of make your data set as anonymized as possible, right? In such a way that your employees do not, mess around with privacy or hackers, right? That can access to, and so on and so forth, right? And then data sparsity. So this is important because what everybody teaches in college, right? When I'm teaching at NYU, right, we go to Kaggle and we have and Kaggle oftentimes show you how hard some data sets are, right? But I would say the most important learning for AI scientists and data scientists oftentimes is just that algorithms are very important, but oftentimes the data set is where you have your first headaches, right? Your first, what, come on, this is really hard, right? Okay, so again, AI scientists discover the first time they put a foot in an asset manager or a bank, the things are always small data. Okay, things are always small data that you just don't never have enough data to be statistically, sure about stuff, right? But life is harder than that. We need to take decisions and build models out of the data sets we have, out of the data sets that we can augment in a smart way using LMMs or gen models. But this also has a lots of caveats, right? So I think this is a good way to do some sort of finish. The idea is we have a new generation of models, LMMs, RL, deep learning, trees, and so on, that are extremely useful to do many of the tasks that are, right. But oftentimes these are really hard problems, right? Because of this data sparsity, with this idea of a sparse word, multiple agent instruction, variability or non-stationarity in regime markets and clients, and so on and so forth. So this is okay. So I think the bootcamp just prepares you, right, for this new generation, so to speak, or of CS people. CS, computer science, and financial engineers in finance will be dealing with all these issues, right? Just a footnote, but there is not a footnote, but agents will be a very important part of the future of finance, right? Agents will be kind of AIs that are that are doing a specific task for you in a data set or in real life, and that have for example, a specific identity. Maybe you create an agent that is the some sort of the compliance person in an M&A deal, right? Or the lawyer in an M&A deal, right? Or the risk person when it comes to a credit loan approval process and all that kind of stuff, right? So I think this is it. We open now for Q&A. No questions? So if you have questions before, send us emails to the info@AIFinanceInstitute.com. You reach out to me, for example, on LinkedIn, right? We're right. If you have questions or if you need references or also if you have special situations, we can consider that when it comes to the course fees, right? So we can adapt. We oftentimes offer a portion of scholarships to some sort of either communities or either students. Yeah, so we're eager also to discuss special situations when it comes to that, and with some sort of given scholarships to people from everywhere in the world, right? So don't be shy.
Michael, have you seen that there's a question in the chat?
Oh yeah, sorry. Oh, that's a very, yeah, quantum computing. So yeah, we'll invite somebody to talk about quantum computing, right? We have a strong hope, right, about quantum computing. I would say that though that um, when we wrote our book on QPO, quantitative portfolio optimization, so we kind of we had a week long discussions about quantum computing, and all we decided was we're going to use quantum annealing, right? But the rest is too emergent to some sort of a span out time, right? You see, so we prefer to spend time in seeing trees or transformers, right? Or reinforcement learning or LMMs, which you can use tomorrow, right? Which you can use today, rather than technologies that can be, very, very impactful a few years ago, in a few years, right? So that's why. But we will, and if somebody can convince us otherwise, I'm happy to give more time to quantum computing. But again, with the QPO book, quantitative portfolio optimization, we kind of discussed and we said, okay, quantum annealing seems an interesting thing. The rest is to be seen. You don't need well, mm, to take the bootcamp. You need if you have a degree on CS, on economics, mathematics, you should be ready, absolutely ready for it, right? The amount, I would say, don't quote me on that, but I think that these days, right, with the amount of tools that we have at our disposal to learn stuff, right? If you have a degree, I have no doubts that you'll do well, right? LMMs can also fill some of these gaps in the sense that, right, you can ask the LMM, how would you do that, right? And now at the beginning, 2 years ago, so LMMs are 2 years old, right? At least the ones we can chat, so GPT-3, GPT-4, and so on. They've done a tremendous progress, right? For example, in coding, right? So now you can ask them to help you in a coding, to document it and so on, to find bugs and so on. And while hallucinations are there, right? They're quite useful, right? 1 hour and statistics for sure, right? That you can train yourself with right. But if you have special needs, again, we'll give you references and materials, right? I think education is going to be accelerated by several orders of magnitude with LMMs, because you have your professor ready for you 24/7, right? If you want to know and study any branch of mathematics, right, at a very high level, of biology, of medicine, of finance, right, you can do that, right, and so on, right? But our opinion is that they still need humans around, right? It's too dangerous to let the kids cooking, right? So the elements can't cook. It's too dangerous, so to speak, right? Yet, okay. But all the knowledge that we all been acquiring, so to speak, over the years about stochastic processes, Brownian motion, this is a solid base that you need to do the finance job well, right? So the shortcut, the process is going to be faster, but you have to learn all this stuff, right? You have to learn all this stuff. What could go wrong if I use this tool in this stochastic process? How sure I am that this time series is following the stochastic process? How sure I am about the factor model I created? How sure I am about an RL model? And so on and so forth. So domain experts are still very much needed, right, in order to not crash the car. Okay. Yes, you can make connections with lecturers. We have a group of people that, in principle, you can reach out to them, right, and ask questions and interact. I think this is a much more open. In the past, professors were kind of, not. But I think today we all interact with a lot of people, right? As far as your requests are obviously, I don't know, interesting, and as far as your requests are kind of reasonable, right? So to speak, we have everybody, They are busy people, right? So it's sometimes hard to get Gordon's time. It's hard to get Stefan's time, my time, everybody of us, right? And not everybody is very active on LinkedIn. Not everybody, but if you're taking the course, all your questions be answered, right? We kind of commit to that. Oh, well, you can patent your algorithms. Obviously, finance is one industry in which the way people has preserved confidentiality is by not telling anybody about what you're using, right? So that's one of the reasons. Obviously, our industry it's not transparent, because you don't want to show the Coca-Cola formula, right, to your competitors, right? I think everybody is kind of more mature these days, in the sense that you can show skin. Maybe you don't want to show all the skin, right? You can still say we have found something, right? If you're working for an asset manager, probably your employer is not gonna let you publish an algorithm that does very well something and so on. If you're a CS, of course, it really depends, all right? If you're a bank, maybe yes, right? But your employers, our professors, some of them are right, and they have restrictions, right? But this is how things operate. But CS has been a much more transparent industry, right? Finance is starting to be more, but again, sometimes people reach out to me to do research, and sometimes they discover that their employers do not let them publish, right? Okay. Typically, employers let you share stuff if it's not related to your day-to-day job, right? So obviously, using data sets of a company, it's a no-go, right? People is not going to let somebody publish findings with a proprietary data set. But if it's a publicly available thing and so on, some employees are more, right? If you're an individual, then it's your judgment to what extent the PR that you will get by showing progress or a new paper and so on, compared to the fact that if you keep that, right, you can use that and so on, right? So I have no answer for that, rather than you should use your judgment to be open source or closed source. You see what I mean? And you're interested in open source when you need PR. So when you need reputation, when you need a new job, and so on, it's good to have a good GitHub with nice stuff there, right? Or show new stuff. So employees appreciate a lot to see nice GitHubs, right? More than nice CVs, right? GitHubs sometimes tell more, right? And again, maybe you want to show there's things that are interesting and keep some under the wraps, and then I don't know. This is again a reinforcement learning problem, right? You have to consider the rewards of being famous because you invented the new generation transformers, right? But at the same time, maybe if you keep that for you, right, you make more money, right, and more, right, yeah. Okay, so I think thank you very much, and yeah, I hope we see you in October. Thank you very much.